Yes, students, let's learn first chapter, real numbers. Let's go through the fundamental theorem of arithmetics. This theorem says every composite number can be factorized in a unique way in the form of primes or can be expressed as the product of primes in a unique way. When we go through an example, it would be clear to you. Let's see an example. Let's factorize a number, a composite number, 120. Let's factorize 120. 120. This is divisible by 2. We get a quotient of 60. Again by 2 you get 30. Again by 2 you get 15. Since it is an odd number, cannot be divided by 2. We know it is the product of 3 and 5. When you divide 15 by 3, you get 5. Therefore, 120 can be expressed as the product of all the prime numbers 2 into 2 into 2 into 3 into 5, or 2 raised to 3 into 3 into 5. This factorization is unique, and there may be a difference in the order of the primes appear. One may first represent 5, then 3, then 2. I have used here in the increasing order of prime numbers. It doesn't matter. In whatever way you express 120, you have 3 2s, 1 3, and 1 5. This is what the fundamental theorem of arithmetic says. Using the method of prime factorization, we can find out the LCM and HCF of a set of numbers. Here we have a set of 3 numbers. First, let's prime factorize each number and express the number in the form of product of primes, then find LCM and HCF. Let's prime factorize these numbers. 48. 48 can be divided by 2, you get 24. Again by 2 you get 12. Again by 2 you get 6. Then by dividing 6 by 2 you get 3. This is the prime factorization of 48. Now let's factorize 72. By 2 you get 36. Again by 2 you get 18. Again by 2 you get 9. 9 is factorized as 3 into 3. Now we have 108. Divided by 2 you get 54. Again by 2 you get 27. Now by 3 you get 9. Again by 3 you get 3. Now let's express these numbers as the product of primes. 48 is equal to 2 into 2 into 2 into 2 into 3, that is 2 raised to 4. 2 raised to 4 into 3. 72 is 2 raised to 3 into 3 square, and 108 is 2 raised to 2 into 3 raised to 3. Now the prime factorization is complete. Now let's be careful to find the LCM and HCF of the set of numbers. Now let's find HCF. HCF means highest common factor. HCF is considered only if the factor is common to all the numbers in the set. Now we have two prime numbers common to 48, 72 and 108. What are the numbers? 2 and 3. 2 is common to all the three numbers and 3 is also common to all the three numbers. Suppose if there is a factor, prime factor 5 for two numbers, it cannot be considered for HCF. First, to check whether the prime number is a common factor of all the numbers in the set. Only if the prime number is a factor of all the numbers, then the prime number can be considered as a common factor. And here we have 2 and 3 as common factor. Now let's see another thing. If a prime number is a common factor, to consider HCF, consider the prime factor having the least power. Here 2 has 4 as power here. Here it is 2 raised to 3. Here it is 2 raised to 2. For the HCF, consider this number 2 raised to 2 into, and again here we have 3s power here, 2s power here, here it is 1, 3. This is the highest common factor because 3 square is not here. We have 3 square in the third number. Second number also we have 3 square, but in the first number 48, we have only 1 3, not 2 3s. Therefore, to consider HCF, first check out all the common factors which are common to all the numbers in the set, and then consider the prime factor having the least power for HCF, then multiply. 2 square is 2 into 2, 4, 4 into 3, 12. 12 is the HCF here. Now for the LCM, least common multiple. We have two prime factors and both the prime factors are common to all the numbers. If so, consider the prime factor with highest power, 2 raised to 4, into, here for the 3 raised to 3 is the number having highest power, 3 raised to 3, that is 2 raised 2 into 2 into 2 into 2. 2 raised to 4, 16 into 27, you get 432. This is the HCF, this is the LCM of the numbers. HCF is 12 and LCM is 432. I think it is clear to you how to find LCM and HCF of the numbers. We'll have a few more examples so that it will be clear to you to find the LCM and HCF of a set of given numbers. Let's examine another example. Find the LCM and HCF of the numbers 36, 45, and 60 by the method of prime factorization. Let's prime factorize the numbers 36. By 2 you get 18, again you get 9, 3 and 3. 45 cannot be divided by 2 because it is an odd number. So by 3 you get 15, again by 3 you get 5. Now let's see 60. How to prime factorize 60? By 2 you get 30, again by 2 you get 15, 15 divided by 3 you get 5. Now 36 is equal to 2 raised to 2 into 3 raised to 2. Now 45 is equal to 3 square into 5. 60 is equal to 2 square into 3 into 5. These are the prime factorization of these numbers. Let's follow the same method that we used in the previous example. Now for HCF, highest common factor, I already told you that to find HCF, we need to consider only the common factors or the number that is a factor, prime number, which is a factor of all the numbers that we consider. We consider 3 numbers here. Then the prime number should be the factor of 36. It should be the factor of 45 and also the factor of 60. We cannot consider 2 for HCF because we do not have 45. We do not have 2 as a factor of 45. There is no 2 here. And also 5 is also not a common factor because the factorization of 36 doesn't contain 5. So we have only one common factor, that is 3. To consider the HCF, we consider the common factor having the least power. Here it is 1, 3 raised to 1, or 3 is the HCF of the set of numbers. And for the LCM, we consider all the prime numbers in a careful manner. See, we have only 3 as common factor for all the 3 numbers, but we have 2 as a factor of 2 numbers. 2 is a factor of 36. 2 is also a factor of 60. If so, we can consider for LCM. We have 2 square here. Here also 2 square. Therefore, we consider 2 square. See, if one number has a prime factor of 2 square and another number has a prime factor of 2 cube, that is 2 into 2 into 2 as prime factorization, then you need to consider 2 cube for LCM. Though 2 is not a factor of one of the numbers. Or even 2 numbers do not have a prime factor and only one number has the prime factor. That prime factor is also considered for LCM. I will show you with another example. And we have 3 as common factor and highest power 3 square into 5 is a factor of two numbers, 5 raised to 1 and 5 raised to 1. So 5 is considered. When you multiply all the three factors, 2 square into 3 square into 5. 2 square is 9, 9 into 2 is 18, 2 into 5 is 10, 18 into 10, 180. 180 is the LCM of the set of numbers. Let's see one more example. 30, 36 and 48. We need to find the LCM and the HCF of the numbers. Let's factorize 30 by 2. You get 15 by 3, 5. 36 by 3 by 2, you get 18. Again by 2, you get 9, 3 and 3. 48 by 2, 24. Again by 2, 12. Again by 2, 6. Again by 2, 3. These are the prime factorization of the numbers. 30 is equal to 2 into 3 into 5. 36 is equal to 2 square into 3 square. 48 is equal to 2 raised to 4 into 3. These are the prime factorization of the numbers. Now HCF. If common factors, consider the common factor, common prime with the least power. Here the power of 2 is 4. Here the power of 2 is 2. Here the power of 2 is 1. We need to consider 2 for HCF. 2 into. Here also 3 is a common factor. The power of 3 is 1 here, 2 here and 1 here. 3 raised to 1 is considered 2 into 3. 6 is the HCF. We cannot consider 5 for HCF because only 30 has 5, 36 and 48 do not have 5 as the factor of the numbers. Now LCM. LCM is equal to the number, the prime factor which is common having the highest power. Here the power of 2 is 4 here, so this number is considered for LCM. 2 raised to 4 into highest power of common factor 3 is 2 here, 3 square into 5 is also considered for LCM, though 5 is not a factor of 36 and not a factor of 48. The factor 5 is also considered to find the LCM because 5 is a factor of one of the numbers. If a prime number is a factor of one of the numbers or two of the numbers or all the three numbers, it should be considered for LCM. Now let's see how to multiply it. To multiply it easily, I consider 2 raised to 3 and 3 square. 2 raised to 3 is 8. 8 into 9, 72. 1, 2 is left. 2 into 5, 10. 72 into 10, 720. Let me explain it. 2 raised to 4 is expressed as 2 into 2 raised to 3 into 3 square into 5. You know 2 into 5 is 10. 2 cube. 2 into 2, 8. 2 into 2, 4. 4 into 2, 8. 8 into 9, 72 into 10, 720. This is an easier way to find the product. I think it is clear to you how to find the LCM of a set of two numbers or three numbers is easier to you. For demonstration, I have considered set of three numbers, which is relatively difficult one. If you are thorough with finding the LCM and HCF of a set of three numbers, it is quite easier for you to find the LCM and HCF of two numbers. I think it is clear to you, and our class on this chapter is continued in the next section, which soon be uploaded.